We have discovered that because of a climate phenomenon called the North Atlantic Oscillation, starting in 2010, there was a large pulse of eastward winds up in the northern Sargasso Sea, very strong and very anomalous, and it very likely would have blown the sargassum from the source in the Sargasso Sea over to the far eastern North Atlantic, at which point, over the period of the next year, the normal seasonal currents and winds would have brought it down south along the coast on the far side of the Atlantic, where it may well have reached Africa and the coastal areas there, beaching on the shores, and then entering the tropical circulation consisting of the north and south equatorial currents and the north equatorial countercurrent. Any floatables at that point would make their way across the tropical Atlantic to the Brazil area and ultimately up and into the Caribbean. And so I think the whole phenomenon with the sargassum leaving its origin in the Sargasso Sea was due to a large-scale wind and current anomaly. And this current anomaly recurred in March 2013, which I believe could also explain the 2010 phenomenon, may have explained the 2011 Sargasso in the wrong place, so to speak. And the 2013 anomaly, doing the same thing but even stronger, may have led to the even more severe sargassum problem in 2015 and 2016.
There are two different species of pelagic sargassum, and there are three distinct morphologies that are found in the North Atlantic region. Sargassum natans and Sargassum fluitans are the two species. Sargassum natans 1 and Sargassum natans 8 are distinguished by their blade characteristics. So natans 1 has thin blades and natans 8 has broad blades. Sargassum fluitans has spines on its stem, whereas the natans complex has a smooth stem, and that's how you tell sargassum forms apart.
So in reference to one species called Sargassum natans 8, we saw a really clear increase in species richness and density of organisms across a transect from east to west in the Caribbean, from the tropical Atlantic to the western Caribbean. So sort of the density of organisms and the number of species can be used to infer about the origin source or where that particular species of sargassum is coming from. Also, genetics can kind of be used to tell that more precisely with looking at the population genetics of things like hydroids that are growing on the sargassum, because different species can also tell origin source as well.
I will talk briefly about sargassum problem in Brazil, mostly in the Brazilian Amazon coast, which is a recent event. It began in 2013, repeating in 2014 and 15. And 15 was the worst year of this series. And so we have now this new problem in the Amazon coast with strandings of massive amount of sargassum, and how do we deal with it? And a lot of hypotheses that emerge from this problem has where did this sargassum come from, and what is this the relationship with the eutrophication of the Amazon coast, mainly by transport of nutrients from the river basins inside the Amazon, like the Araguaia, Tocantins Araguaia, Xingu and Tapajós river basins. And also we are analyzing associated invertebrate fauna to take a close look if its fauna can help us to explain such hypotheses.
Our research has shown that increasing nutrient runoff from land-based sources is increasing the productivity and growth of pelagic sargassum. We did research in the 1980s that showed the highest growth and productivity of sargassum were in neritic or nearshore areas as opposed to oceanic populations. So as we as humans generate more nitrogen and phosphorus runoff, that is resulting in increasing biomass of sargassum. However, the actual arrivals of sargassum or the influx on a particular island are influenced more directly by winds and tides and currents that then transport that biomass to a particular location at a given time.
And sargassum can be detected by satellite imagery, and we can use these images from the MODIS capture on satellite Terra and Aqua to use for prediction of Sargassum landings. There has been a lot of work done by University of South Florida, and there is available tools online, free products that can be used to for monitoring and tracking of Sargassum in the Caribbean area. These images cover the whole Caribbean Sea and also the Western Atlantic, and you can download these pictures on Google Earth associated with surface current from the HICOM model, and use this information to locate the Sargassum raft with GPS coordinates, look at the average speed of the currents and orientation, and use this information to do some forecasts for Sargassum landings around your islands.
The question is about the prediction scales for the Sargassum events that are occurring both on this side of the tropical Atlantic and off Africa also. And the answer to that basically is we're in the very short-term scale. Within the next few days, we're hampered considerably by cloud cover and the ability to spot it with satellites. And an intermediate scale, which I'm addressing at this conference, is whether we can spot it over the several months offshore and then predict its arrival in the Lesser Antilles. And the answer to that is it, again, very much hampered by cloud cover. We're in the intertropical convergence zone in this area, and by which model currents to use. But it is predictable within several weeks over a scale of 2 months. On the long-term scale, I think we have a good shot at predicting seasonal scale because of the tropical dynamics, tropical North Atlantic equatorial dynamics, and their relationships to the climate indices of the entire North Atlantic. So once we get that relation down, the formation and example of the formation and dissipation of the North Equatorial countercurrent and its relation between the connection of the eastern side of the tropical Atlantic and the western side of the tropical Atlantic, and I think we have a shot at predicting the intensity of each season.
Why is looking or examining fishery sector in terms of the Sargassum events? It is important because a lot of Caribbean islands depend on fishery resources economically, socially, and culturally. In Barbados, fisheries plays a large part of the culture and the economics of the island, and it was important to look at the impacts the Sargassum influx events were having on the fishery sector, looking at the effects through the fishery value chain from boat owners, boat captains, fishing crew, vendors, scalers, straight through to seafood processors and restaurants. Fishery contributes a great deal to the GDP of the islands in the Caribbean, and it affects fishers and fisher folk personally. Their ability to make an income and their ability to carry out life daily is affected by the Sargassum influx events. So we at SERMIS thought it was important to look at the socio-economic impacts and how the fisher folk actually adapted to these impacts. How were they coping day to day with these negative impacts, and how would they cope in the instance of future events, or what were their adaptive capacities?
And I think one of the most important lessons we've learnt through these mass inundations of Sargassum is to share information, to communicate and share the lessons that we've learnt to prevent the same mistakes being made in different countries or by different groups of people. So getting the public involved, sharing the facts and sharing the lessons learnt with cleanup.
The 69th GCFI being convened here in Grand Cayman is the perfect venue, the perfect place to have lengthy discussions of the science, both biological, socio-economic, oceanographic, the science surrounding the sargassum issue that's been occurring in the region since 2011. So my particular interest at this time, at this meeting, is in sargassum. We've heard a number of good scientific presentations. We've had some good dialogue that will continue throughout this meeting. Sargassum is such an important issue. There are many needs yet that we have identified. So we need information, we need input, we need resources, and we need collaboration among researchers to help address this sargassum phenomenon and this sargassum issue.
We are very pleased that this 69th GCFI annual meeting is very rich in terms of information related to the sargassum influx, with the poster session, with the informative event we had yesterday night, which brought interested exchanges, and of course with the technical session we had this morning with 9 great talks for which all the presentation will be available on the SPORAC website. So I want to address special thanks to our partners, the UNEP Caribbean Environment Program, the CERMIS Laboratory of the University of the West Indies, the Sargasso Sea Commission, the Association of Caribbean States, and UNEP Global Program of Action and Global Partnership on Nutrient Management. As we still have a lot to learn to understand this phenomenon, we will continue to work together to address the issue by developing responses at regional scale, but also global scale, owing the transatlantic dimension of this phenomenon. So please stay tuned for more information on our different websites and also online network.